by capital Q or small q, right? I think this you must be knowing. Hmm? Yes or no?
Yes, sir.
Okay, write it down, then we'll move forward. One thing also we can say about the property. I mean, we can just discuss, but we'll study it later. That what is the effect of this charge? So we can see that this electric charge or property associated with matter. So, and what does it do? It experiences electric and magnetic effects, right? So we can write that also. I mean,
Yeah.
we'll be studying that later, but just write it.
Okay.
Which experiences electrical and magnetic effect. Hmm.
Sir, this is the definition.
Hmm. Sorry.
Which is the definition?
Yeah, that's the definition of electric charge. How we denoted it? We denote it by capital Q or small q, depends upon you, whatever you feel better. Now, talking about, for example, if you are purchasing something, like let's suppose you are purchasing vegetables. So how do you like what quantity do you use? So you use kgs, right, to measure them. Similarly, what quantity will I be using for electric charge? Like if I have to measure charges, so what will I be using? So that is called the SI
Column.
units if we talk about, right? So the
Yeah.
SI unit for charge will be
Column.
coulomb, denoted by capital C, right?
Then what is Q?
Hmm?
Then what is Q?
Q is the charge. Okay. For example, if I say that you have cloth, so cloth you measure in meter, right? And I am
Yes.
denoting this cloth
Yes.
by C, or like let's take K. So this is this charge. Charge I denoted by Q or small q. And I am measuring this charge in what unit? In coulombs. That is by capital C. Got it? Hmm.
Yes.
Write it down, the SI unit of coulomb is SI unit of charge.
Yes, sir. Sir. You know,
Hello, am I audible?
yes, sir.
Maybe some Glitch must be there.
Yes.
Yeah, what I was telling you? So I was telling that, yeah, let's suppose you are buying something, and so you ask them in kg, but let's suppose you are buying something light in weight. So, for example, let's you want chilies, which are light in weight. So you would want them to measure in gram, right?
Yeah.
Hmm. So similarly, so you can see that kg is a bigger unit and gram is a smaller unit. So this bigger
Mm.
unit is called SI and smaller is called CGS.
What?
Okay. This smaller is called CGSU. This is SI unit and this smaller one is CGS unit. Okay. What
Okay.
is it called, the smaller one?
CGS.
Hmm. Similarly, if we ask, so I told you that the SI unit of charge is coulomb. Now we'll also have CGS unit. Like a bigger unit to measure charge is coulomb, and a smaller unit, CGS unit, will be stat coulombs.
Which columns?
Stat coulombs, STAT stat coulombs. Okay,
So
write it
are you
down.
sharing screen?
Sorry, yeah.
Are you sharing the screen?
Oh, wait. I think, oh, visible now?
Yes.
Hmm. So, yeah. So I said that like the bigger unit we had kg and the smaller was gram. Similarly, the bigger unit to measure charge is coulombs, and the smaller one is stat coulombs.
Stat columns.
Yeah.
Okay.
Hmm. Now we are talking about charge. So where is this charge all present in the universe? So where does the charge? Where is the charge present in universe? Right? We're talking about our universe. So in this universe, where is this charge all present? Like we're talking about charge, but how is this charge present? How can we see this charge? How can we feel this charge? So we know that the smallest quantities that we know which carry charges are electron, proton, and neutron, right? Electron has negative charge, proton has positive charge, and neutron has what kind of charge?
One.
Have you heard about neutron?
Yeah.
Neutron has neutral charge. N for neutron, N for neutral. Tell me what is the charge of electron?
It's negative.
Speak louder.
It's a negative.
And the charge of proton?
It's positive.
And neutron is
Neutral is neutral.
neutral. Okay. Now there are two words which we should, before writing, see this, that we say that something is charged and something is uncharged. So basically something which has charge is called charged and something which does not have charge is called uncharged. Now this electron has negative charge. So this is charged, right? Proton has positive charge. This is also charged. So neutron, we say neutral. So this is very important point to notice that it doesn't mean that it is uncharged. It means that the positive and the negative charges are equal. So it is neutral. For example, we have 1 plus 1 minus. So this plus and this minus cancel each other, which means charges are there, but they are canceling each other. So we say it is neutral.
Yes.
Understood?
Mm.
Any
So
confusion?
neutral.
Hmm.
So
Neutron
neutral
is
is
neutral.
positive and negative.
Yeah, neutral means it has positive charge also, also negative charge also, but the positive and the negative charges balances each other.
So it will always be equal.
Understood? Yeah, they must be equal. That means in neutron, the positive charge is equal to neutral means positive is equals to negative,
Mm.
right?
Okay. Yes.
Now, we were talking about where is the charge present in this universe. So this electron, proton, and neutron, they have different charges on it, right? Negative, positive, neutral. Now they combine and they form ions. They combine, they forms ions. Ions, they forms molecules, and molecules forms atoms. And we know everything in this universe is made up of atoms, right? That is how
Yeah.
charge is present in the whole universe. Write it down.
Yes, you're done.
Hmm. Okay. Now I talked about Coulomb, right? So we have, like I told you, we have kg, gram, milligram. Similarly, in this Coulomb, we had a bigger unit called Coulomb and a smaller called Stat Coulomb. Okay, but we have some other smaller units. For example, 1 Coulomb is equals to 10 power 3 millicoulomb, and 1 Coulomb is equals to 10 power 6 microcoulomb. Write it down. This is milli and this is micro.
Yes, sir.
I'm not able to listen you.
Yes, sir.
Speak. Huh. Written.
Yes, sir.
Okay. Okay. Tell me, what is the SI unit of?
Sir, your mic is off. Sir, your mic is off.
Sorry. Yeah. So I was saying, what is tell me the SI unit of charge?
Column.
Hmm?
Column.
Coulomb. And what is the CGS unit?
Stat column.
Stat Coulomb. Yes, very good. And what else did we see? Till yet? Okay. And electric charge is a property, and all the charge in this universe is present as.
Positive, negative, and neutral charges.
Hmm. Okay. Now talking about the types of charges, as we said, there are two types of charges: negative and positive. So how we see the representation of these charges? Okay, let's suppose if I make a positive charge. So if you see, I mean, we have developed some theory to study the charges, right? That what will be the function of these charges. So if scientists have said that positive charges, if you observe them, so it feels like that the rays are emerging from it. Positive charge is like that rays are emerging out from it. And negative charge is like rays are going into it. Okay, always. This is always true. In negative charge, so we assume that in positive charges, the rays are going outward, and in negative charge, the rays are coming inward. Write it down. Now this positive charge can be a proton, and this negative charge can be an electron. Okay. Done.
Yes.
Hmm. Now you must have heard a statement that unlike charges attract each other. You must have heard, right?
Yeah.
Hmm. So let's see how does it happen. First, let's write that unlike charges attract each other. Let's take two unlike charges. Let's take a positive and let's take a negative. Two unlike charges, right? So what was the direction of rays in positive charge?
It was outwards.
Going outward. Okay. So I made this. And electron was coming inward. So you see
Yes.
the rays, eh, it is going in the same direction, right? So which means it is trying to pull each other, which means they will come close to each other. And when they will come close to each other, so there will be attraction equals to attraction. And then we say that like charges repel each other. Let's take two like charges. Let's take a proton. See here first. We have taken two protons. Now you look here. They are, since see, both of them are pushing each other. These and these rays are like this, right? So they are pushing each other. That is why they go away from each other. So equals to repulsion. We can also see this with electron. See with electron. See this arrow. Look here. This arrow is trying to take the electron this side, right? This side. And this electron is trying to take the electron this side, which means they are moving far, right? They are moving far away. This electron is trying to take this electron this side, and this arrow is trying to take the electron this side. So they are moving apart. So which means repulsion. Understood?
Yes.
Hmm. Make it. And
Yes, sir.
should we move forward?
Yes.
Now, how the charge appears on a body. How charge appears on a body. Okay, now we're talking about this charge is coming on a body. Now, how is charge coming on a body? How is charge appearing on a body? So it happens by
Body means
uh,
body means
and appears on a body. Body means some sort of, for example, a matter we are representing as body, right? Appears on a body.
yeah.
For
Like
example,
what
we're
is body?
saying, for example, I talk about a ball, right?
Yeah.
So now what I say is that you have a ball in your hand and you are rubbing this ball against a wall. So what happens? Some charge comes on this ball. So this ball is a body.
Yeah. Okay.
Okay,
Then
that is the
the
meaning
wall
of
is a
ball is also a body. Both are body because charge is getting developed on both, on a wall also and the ball also.
yes.
So both are body. Okay. Now how this charge appears on a body? It happens by breaking the neutrality. Happens by breaking the neutral condition. By breaking the neutral state. Okay, what I told you was the meaning of being neutral. It means that number of electron is equal to number of proton. This was neutral, right? So
Yeah.
if some body is neutral, will it be having any charge,
No.
right? So the body would be neutral, and because electron equals to proton, so no charge is there. Now you want to bring charge on the body. So what you will do? You will give some electron or you will take some electron. So how does the charge come on a body? It happens by breaking the neutral state. And how we do it? So this is done by
So electrons and protons together is neutrons.
no.
So
What repeat, what did you say?
electrons and protons together is neutron.
Total number of, when the number of
Yeah.
electron is equal to number of proton, then only you say neutron. If you have
Okay.
3 electron and 2 proton, will you call it a neutron?
Like two neutrons.
3 electron and 2 proton in one body. Will this body be
We call
neutral?
it no.
So we cannot call it a neutron. It should be equal.
Okay.
Hmm. Now, I told that neutral state is broken by 2 ways. Number one, giving electron or taking electron. Okay.
Hmm.
So how, like for example, I had a body, it is neutral, right? Neutral means electron is equals to proton. Okay. Now you
Hmm.
want to charge this body. You want to bring charge on this body. So what you do? This is done by breaking the neutral state. This is a neutral state. We'll break this. And how we will be doing it? By giving electron or taking electron. Okay. Let's suppose in condition number one, what I do is I give this 2 electron. So now this body becomes negative. Okay. And in second condition, I like here I am adding plus 2 electron. And if I take 2 electrons from it, so this body becomes positive. So
Yes.
how we gonna write it? That if you take electron, then the body becomes positive. If you give electron, the body becomes negative. Why?
If we give electron, the body becomes positive.
If you are, see, here I added plus, which means I am giving electron. If I am giving
Uh,
electron, what is the nature of electron? Negative. If
Yeah.
I am giving you something negative, you will become negative, right? So here, if I am giving electron, so you will become negative. And if I am taking out the electron, then you become positive.
Yeah. Yeah.
So we'll write it as, first you write this, then I'll tell you how to write this. First you write this.
Yes, sir. Yeah.
Which means that if I will give you electron, you will become negative or positive.
If I give electron, I'll become
If I
negative,
give you
positive.
electrons, I am giving you electron, means you are taking electron. If you are taking
I'll
electron,
be,
you will become negative or positive.
I'll become negative,
And if you are giving me electron, then you will become
positive.
positive. Okay. And this is how body
Yeah.
is made negative or positive. Okay. Now let's suppose if I say
Yeah.
that there was a body, okay, and I give uh, 10 electron to this body. So what will be the final charge? How will the body become? And will it become positive charge or negative charge?
Become negative charge.
Negative.
Can't we give proton?
See, protons are not given. Only electrons are given. Why? There is also a reason. Okay, now listen. Let's suppose if um, you have a pen and you have a almirah, which is easy to move. Pen or almirah?
Pennies.
Pen. Why? Because pen is smaller in
Small.
size. Pen is lightweight, so you can easily carry pen with you. You can move the pen, but you cannot carry almirah. So that is why electron is very small and proton is big. Since electron is
But
very
both
small,
are
so it
the,
can move easily. So we can transfer electron. We can give or take, but it is very difficult to give or take proton. Okay.
but both are the same amount of charge.
Yeah, charge is same, but it is very heavy. So we usually what we do, we give electron or take electron. We don't give and take proton. It can be
Yes.
done, but it is not usually done at your level.
Yeah.
Hmm. If a body I give 10 electron, it become negative. Now, if I tell you that there was a body which had 3 electron and 3 proton. Now, if I took out minus 2 electron, then the body will become
It will become positive.
positive. Why? Because there were 3 electron early and I took out 2 electron. So how many electron left? 1 electron, right? So the body now
Yeah.
has 3 proton and 1 electron. Now this is positive and this is negative. Now you see, positive is 3 times, positive, 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 and negative is only 1 time. So that is why you say the body become positive. So this is the reason how it becomes positive. Understood?
Yes.
Now you say the body becomes positive. Okay. Tell me in third case. If I have a body and it has 4 proton and I give 4 electron to this body, what will it become?
It will become neutral.
Neutral. Very good. Write it down. Understood, Umer?
Yes, sir.
Any doubt?
No.
Write body. Don't write body, write neutral body. Right here. Neutral body. This is neutral body. And this is also a neutral body. See, here no charge is there. So neutral body. Here electron is equals to proton. So neutral body. And what kind of body will be this?
That will be positive body.
Positive body. Very good.
Done, sir.
Done.
Yeah.
Hmm. Now we'll talk about quantization of charge. What is the meaning of word quanta? If I talk about
Quanta.
this word, quanta. So quanta means packet, right? Okay. Before explaining this, I'll explain you a short story so that it becomes easy. Okay. Now you go to a shop and you ask for fruits. Now the shopkeeper has done one thing. It has made packets of apples, right? It is not selling one apple or two apple. It has made packets. Okay. So one packet has 1 kg apples. Okay. Now you tell me. So if you, and he's selling packets only. Okay. Umair.
Yeah.
So packets he's selling now. So you can go, you can ask for 1 packet, 2 packet, 3 packet, or 4 packet, right? Now if you go and ask him that
Yes.
you want 4 apples, will he give you 4 apples?
No.
No. He will say that you will only have to take packets. You can take 1 packet, 2 packet, 3 packet, but you cannot take, like, you cannot take half packet. That is not possible. If you want, you go, you say I want half packet, so he won't give you. Similarly is the quantization of charge. Okay. So what is the minimum charge that a body can have? The minimum charge that a body can have, minimum charge a body can have is called E. Is called E. E means electrical charge, not electron. If I write E minus, that is, this is electron. This is only E. Okay, don't get confused. So this E is electrical charge. Okay. Now, I told you, for example, I tell you that Umair, you can have only 1 apple with you. So what you will see that the minimum apple you can carry is 1. Similarly, what is the minimum charge a body can have? That is called E. And what is the value of E? So E is equals to 1.6 into 10 is power minus 19 Coulomb.
Okay.
What is the minimum charge a body can have?
1.6 into 10 to the power minus 19.
This is the minimum. You cannot have anything less than this. This must be required at least to have a charge on you, right? And this is the value of E. Okay. And E is electrical charge, right? Now, if you write Now if I have to write that, what is the charge of an electron? So if I write charge of an electron will be, because electron is negative, so I'll say minus 1.6 into 10 to the power minus 19 coulomb. And if I ask you what is the charge of proton, so you will say, because proton is positive, so plus 1.6 into 10 to the power minus 19 coulomb. Understood?
Yes.
Okay.
So electric charge can be negative also, right?
Yeah, see here, this is negative. Electric charge of electron is negative. Electric charge of proton is positive.
Hmm.
See this minus sign.
Yes.
This is E, electrical charge, and this is E negative electron. This is P plus proton. Okay. Now coming back to the topic, we were talking about quantization of charge. So this is the minimum charge a body can have. Now you want to charge a body. Now the body will
Can't it
be
have
charged.
two?
Huh?
Can't it have two electrons?
Wait, and this I'm telling. Now I want to charge the body. See, this I said this is the minimum. Now we'll increase, na? Now we'll go to maximum limit. Now you can increase the charge by Q is equals to NE. This is the formula. When I give one now
Number.
N means number of electrical charge. Hmm.
Yeah.
Now you tell me, what will be the charge on a body if I give it one electrical charge? So if you say, if I
It
give
will
you
be
one,
same.
so 1 into what is the value of E? 1.6 into 10 to the power minus 19, which means what is the smallest charge you can have on a body is 1.6 into 10 to the power minus 19. We already saw this, right? Now,
Yes.
if I
Yes.
tell you that I am giving two electrical charge to a body, so you will say Q is equals to NE, N is equals to 2. So this becomes 2 into 1.6 in 10 to the power minus 19. This will be, what will it be?
3.2 10,
3.2 into,
3.2 10 to the power
hmm,
minus 19.
yeah, 3.2 10 to the power minus 19. And similarly, if I say um, N is equals to 3, so you will say Q is equals to 3 into 1.6 in 10 to the power minus 19. This becomes
4.8 into 10 to the power minus 19.
4.8 into 10 to the power minus 19 coulomb. Understood? Write it
Yes.
down. First write this.
So then if there is
Hmm?
two electrons, if there is two electrons, it will be minus 3.2 into 10 to the power 19 coulomb, right?
Minus sign only denotes what kind of charge you have used. You have you use a negative charge or positive charge. Okay. It doesn't mean that the charge is a negative.
So
Understood?
if it is minus 3.2 means it is less than 1.6, right?
No. That doesn't mean that everything is greater than one. Everything is great. See, everything is greater than this number. Don't say one. Every charge will be greater than this number. If you have minus, that means I have given electron, and if it is plus, that means I have given proton.
So minus plus is just symbols only,
Yeah, it is
not
just
value.
to show that it is electron and proton, because everything will be greater than this value. This is the minimum that that body can have. Note it. What is the value of E?
Is minus 1.6 10 to the
Only
power 9.
did I say electron? I only said E. Don't say minus plus. Say 1.6 10 power minus 19. If I ask you what is the value of an electron, then you say 1 minus 1.6 10 power minus 19. Okay.
Okay.
This E electrical charge is the fundamental, it is the elementary unit. You can write it down also. It is the elementary unit. When you have done writing, then tell me, and I'll scroll
Yes,
the screen. Done?
Yeah. So if it is proton, should we give the positive sign or we don't need to give the positive sign?
Yeah, proton means positive sign and electron means
Mm,
negative sign. Now in this Q and E, so what is E?
Like amount of charge.
Electrical charge. What is N?
Number of electrons or protons.
Number of electrons. What is Q? It is the
Q
total
is
charge. Okay, write it down.
E is number of N is number of electrons.
Yeah,
Can't it be number of proton?
I just told you we don't give protons, we don't take protons. We add electrons only. Then
Yes,
writing.
sir.
Hmm.
Yeah.
Will you do a question now?
Yeah.
Hmm. So if I say a body is charged with 5 electrons, find the total charge on the body.
Eight minus 8 into 10 to the power minus 19.
What is E?
E is 1.6 into 10 to the power minus.
What is E? What is the meaning of E?
E is 1.
Electrical
Electric
charge.
charge.
So we don't put minus plus minus here. You can add, but generally in the question, so if you also have to write, if you're writing minus, so we'll say that Q is equals to NE, which means 5 into 10 is power, sorry, 8. This becomes 8 into 10 is power minus 19 coulomb. And if you write negative, then you have to say the negative sign shows that the negative signs depict electrons, that it is charged with electrons, right?
Yeah.
So you can say minus 8 into 10 to the power minus 19 coulomb. Okay. Now, second question, tell me.
Down should I write negative means electrons?
Yeah, right, it's okay. But if it isn't mentioned in the question, then you have to write the negative charge means the negative sign means that it denotes the electrons. Can a body have a charge of 5 into 10 to the power minus 19 coulomb?
No, sir. Can't have.
No, why?
Because quantization means only
Because we
full
do q
number,
is equals
whole
to any,
numbers.
and they have given the q, the total charge. So 5 into 10 to the power minus 19 is equals to n into e is 1.6 10 to the power minus 19. This will go here and divide. So the value of n we are getting is
Some decimal number.
hmm, something in decimal, right? So this answer would be 3.12.
Yeah.
3.12 I'm getting. Now, I told you I can give one electron, I can give two electron, can I give electron in decimals? That is not possible. Okay, so that is why it is not possible. Because also write one thing here in this here that n should be 0, 1. I mean, what is the minimum thing you can do? Give no electron. In that case, n will be 0. Else you should say it would be 0, 1, 2, 3, 4, 5, 6, and so on. No decimal, no fraction. Okay.
Yes.
Hmm. So which means a body cannot have this charge. So a body with a charge 5 in Tesla minus 20 coulomb is not possible. Understood?
Yes.
Now let's do one NCRT question. You have CBSE board, right?
Yeah.
Okay. Let's do one NCRT question. Find the number of electrons on a body having 1 coulomb charge. Did you get the answer? I got the answer.
I got it in decimal, sir.
Hmm?
I got decimal.
How much answer you got? See, I got 0.625 into 10 to the power 19 after solving this. So we can write it as 6.2 by 10 to the power 18. You won't say it is a decimal. I mean, it looks like a decimal, but it is not decimal. Why? Because it has 18 zeros after it. So what we can do? We can remove two decimals and we can reduce the zero. We can make it 625 into 10 to the power 16, right?
Yeah. Yeah.
Which means these many electrons are there, which means 6 to 5 and add 16 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. These many electrons are there in 1 coulomb of charge. Don't think it is in decimal because 10 is power 18 is there after that, right?
Yes.
This is a whole number.
Mm.
Hmm. So you write this 6.25 10 to the power 18 electrons are there in 1 coulomb. So we can write a statement as 1 coulomb, right? You've written this, done this till here?
Yes, sir.
Hmm. Right. 1 coulomb is equivalent to the charge contained in 6.25 into 10 to the power 18 electrons.
Okay, sir.
Done.
Yeah.
Hmm. And let's do practice of one more question. Okay, I'll give you one question. Wait. Hmm. This question. Total charge on a body. Total charge on a body is 19.2 into 10 to the power minus uh, 19 coulomb. Right? ठीक है. Now find the number of electrons.
Sir, 12.
12. Yes, very good. So number of electrons you got 12. Hmm. Any doubt in any part? Whatever we saw today?
No, sir.
Hmm? Everything clear?
Yeah.
Okay then. Thank you so much. Hello, Rohan. Am I
Hello, sir.
audible?
Yeah,
How are you?
fine.
Hmm.
Yeah, fine.
How's your sinus?
Um, the same.
Let's
I
start
don't
with
always
sinus.
sinus, it just comes and goes.
Huh?
I don't always like have sinus, it just comes and goes.
Okay, okay. Let's start with science today.
Science,
Yeah,
maths, right?
they mentioned maths, but I've changed it to science because yesterday only we saw maths. Let's see science today.
Yeah, I was confused why we were taking maths today.
No, I changed it.
Hmm. I have to take the books once again. Yeah,
Hmm. Ready?
yes,
Hmm. So the chapter that we are going to deal with is conservation of plants and animals, right?
yeah.
What do you understand? Who was added? Who all are there in the meeting? What participants? Names. Yeah. So what do you understand by conservation?
Like preserving something.
Preserving something. Why are we preserving something? Like, do we preserve mosquitoes or flies?
No,
So
because they
why
don't
do
do
we
any
do it?
use.
Huh?
They're useless.
They are useless. Um, Something like humans are useful, right? But we're not uh, conserving human beings.
Uh,
Why does this need generates? Whenever you see some chapter, na, try to like go behind the topic that what is the meaning of this chapter? Conservation. Why are we trying to conserve something? What is the need to conserve something? Just because they're useful.
yeah.
Have you heard of